Hello, today we're going to look at how we can factor long polynomials that pass trinomials. So, with methods we've learned of factoring, we've learned that you can use trinomials, use the X method, we could look for GCFs. We also looked at grouping. If the first two items have something in common, you could pull out, which this would have x squared, and it would leave us with 6x plus 17. And then you could go over here and say, is there anything common? And as long as you get, whenever you pull out your common factors, if you get a parentheses that match each other, it can be factored that way. But oftentimes, like this case, we will not end up with such an item. Without even continuing on, just think about it. If you took out an x squared here, this first term is larger than, the first term is smaller than the second term. The second term is larger. But over here, when we factor out what's common, this term will be larger than that one. So the parentheses won't match. So if you can't do that method, there's always the division method, okay? So division works like this. You know this. You write out your terms. 6x cubed plus 17x squared minus 104x plus 60. Now what you want to make sure you do when you write out division is you're not missing any powers. Like for example, if this was x to the fourth and this was x squared, you'd want to make sure you include like a 0x cubed. There's something, a space keeper, if you will. Now what we do is we draw our division line, just like you learn in grade school, and then you put your factor over here, which our factor is 2x minus 5. And what you ask yourself is, what do you need to multiply this term to give you this term? Which in this case, it would be 3x squared. We would need 3x squared to be multiplied. So if I multiplied by 3x squared, 2x times 3x squared is 6x cubed, and then negative 5 times 3x squared would be negative 15x squared. Now the rule with division that people forget when we get here, just because this is more complex, but in simple division you do this automatically, is we always subtract these. So what that means is we need to switch every sign before we continue. So that's just a rule of division. That sign switches, so those go away, those are gone, and now I'm left with here 32x squared, and I pull down my next term, minus 104x. So now I'll ask myself, what times 2x will give me 32x squared? Well, this time it's going to be 16x. So I'm going to come up here and put plus 16x. So that would give me 32x squared. Negative 5 times positive 16x is negative 80x. Now again, what do we need to do? We need to go through and switch our signs. So I draw my line, I switch these signs, those cancel, and now I'm left with negative 24x, and I pull down this number, plus 60. Now I ask myself one more time, what do I need to multiply by 2x to get negative 24x? I need to multiply by negative 12. If I multiply by negative 12, I would have negative 24x. Negative 12 times negative 5 is positive 60. And finally, last step is, again, you switch signs. So this becomes positive, this becomes a negative. Those cancel, 0 remainder. Now, if you have a 0 remainder, what that means is you have factored it. Okay, so that means 2x minus 5 times 3x squared plus 16x minus 12 is equal to the original. Okay, now we could factor this even more. How do we factor this even more? It's by doing a x method here, because this is now a trinomial. You first look for something that's a GCF, which we do not have. So then I would draw an x. And so remember, this is A, this is B, this is C. And so A times C goes on top, which in this case is negative 36. And the B goes on the bottom, which is 16. Now I can think of the factors 18 and 2. 18 and 2 would work. Now which one would need to be negative to give me positive 16, but negative up there? It needs to be the negative 2. So my A term, I split the power in half, but that comes down. So I'll have 3x plus 18 and 3x minus 2. This has something in common that I can reduce. 3 goes into both of these, which means I'm left with x plus 6 and 3x minus 2. These are the factors of that, and let's not forget that 2x minus 5, so I'll put that on there, 2x minus 5, and these would be my factors. So all that work, and we have factored our equation using long division. That's long division for you right there. And finally, I added some vocabulary for you. The quotient is up here, and so we had the factor, the quotient. Factor times quotient would give us our original value here. This is completely factored.